Hello students, welcome to part 2 of my video series of beetles and beavers, or beavers and beetles, or beavers and the beetles. No, it's beavers and just beetles. Okay, what we're going to do today is take the information that we used yesterday from the scatter plot, and we're going to find a residual plot. We're going to interpret R squared value, which is the coefficient of determination. We're going to calculate S, which is the standard deviation of the residuals, and we're going to interpret that as well. So first thing we need to do is some hefty graphing calculator work. So you're going to have to follow along. You might have to watch this a couple of times to get it, but it's worth it if you can do it on the calculator. Okay, so what I'm going to do first is go into my lists, and what I want to do is something interesting, something that I don't think we've done before. I want to calculate the predicted values of all of these x's. And how do we get the predicted values? Well, we use the equation of the line that we got earlier. So it's interesting, you might have not thought that your calculator could do this, but you can actually type formulas into the list. So what I'm going to do is type in what I want, negative 1.29 plus 11.8938, and I want it to take x. Now x is L1, so I need to tell the calculator to go to L1. And this is a very important skill that you need to be able to do, is name the lists. What you have to do is go to second stat. See where it says list right here above stat? And I want it to choose L1 because that's our x value. And then hit enter, and it actually will plug in all of these values for you into the equation. And these give me the predicted values. Now why is that useful? Well, it's useful because the residuals are y minus y hat. And these are y's, they're the actual values, and these are the y hats. So I can do this again. I'm going to go here, and I'm going to tell L4 that I want it to take the y's minus the y hats. And there are your residuals. And that's really exciting because you can make a residual plot out of this data, and you can also use it to find the standard deviation of the residuals because you have them all listed. Now, as I mentioned in the lecture and in the book, you can't do the standard deviation in the one variable stats because in the residuals you do n-2, not n-1, so it's not going to come out correctly. But I'll show you a way to calculate it using your graphing calculator that won't be too bad. Okay, so first let's just do the residual plot. So first thing I want to do is make a plot where L1 is x, because that's still the explanatory variable, but now my response variable, my y, is going to be the residuals. So I need a plot of L1 to L4. So what you want to do is go back into your stat plot up here. I want to do two things. I want to turn this one off. That's our old one that just shows the regular scatter plot. Then I want to come here and turn this one on. I want to turn on my second one. And as you can see, I've already got it set up. But down here, you need to make it have L1 and L4. If you forgot how to put the lists, what you do is you go second, stat, and it gives you the lists, and then hit 4 for L4, and it will do L1 to L4. The other thing we need to do is turn off our line. We still have our line graphing, so we need to go to y equals, and I don't know if you've ever known you could do this before, but go over to the equals and deselect it so that you won't see it. Hit zoom 9, and there is your residual plot. Let's check it. Looks pretty good. Looks pretty good. So it looks like I made my residual plot exactly like the one off the calculator. Now I made mine, I copied off the calculator this time. So let me show you how I did that. I went to trace, and it gave me the first value. And my residual here was at 2, -12. Now, one nice thing about a residual plot is your x-axis is always going to be the exact same as your scatter plot. So I just did 1, 2, 3, 4, 5. To scale the y-axis, I went down to the lowest one, was -12, so I figured, well, -15 would be a good value to go by. And then my highest one, I'm just tracing along till it gets up here. Okay, it was 8.6. Well, I had extra room, so I went up to 15, but I could have just gone up to 10. And then I traced along the points and graphed them all on my residual plot. So here's the point 5, -2.1. So I went to 5, -2.1-ish, and made a dot. And that's how I graphed my residual plot on my paper. Okay, so that's done. Now I want to talk about the value r squared. We found it yesterday. It was 0.84. But today I taught you how to interpret this value. And it means, and I hope that you guys have this, starting to get this down in your head, 84% of the variation of beetle larvae, you always want to pick the y value, is accounted for by the least squares regression line. And that's how you interpret that value. Let me say it again. 84% of the variation of the beetle larvae is accounted for by the least squared regression line. Okay, last thing we're going to do is calculate S, which is the standard deviation of the residuals. This is important because it tells us how far apart the residuals are, an average residual, basically. So, as I mentioned, we can't do it in one variable stats, which is disappointing because we really want to be able to do this quickly like we can with the other points. But unfortunately, we're doing n-2 on the bottom instead of n-1, so we can't do that. But I'll show you another way to do it. First thing I did was I counted up my data points, and there were 23 of them, so I did 23 minus 2 on the bottom. And then here's my trick. And there's a couple of different ways to do this, but what you can do is go to your residuals, which is in L4. You can actually, if you're not a graphing calculator person, but you're a listing out person, you could take all of these numbers and square them and add them together, and that would go in the top of your fraction here, and then we take the square root. I, however, am not someone that wants to list out 23 squared numbers and add them together. So what I'm going to do is use my new trick of formulas in the graphing calculator in the list. So what I'm going to do is tell L5 that I want it to square all of the numbers in L4. So I'm going to go to second list 4 for L4, and I'm going to tell it that I want to square them all. Now what does that do for me? That gives me this part of the formula, the residual squared. Okay, now I need to go out to the regular part of the screen. And what I want to do now is add them all up. This is the sigma notation, which is a really poor sigma notation, but it means add them all up. I want to add up everything in column L5. Okay, now you might not have known your calculator could do this either, but if you go to second catalog, you get a list of things you can do, and one of them is sum. So I'm going to go down to S and down to sum. Here it is. And I want to sum everything in L5. So I'm going to go back here and I'm going to tell it L5. And there it is. The sum of L5, those are my squared residuals, is 865.38. Okay, 865.38. And then I'm just going to divide that number by 21. And then take the square root. 6.42. So S equals 6.4. Okay, S equals 6.4. Now what does that mean? That means the average residual, or the typical residual, is 6.4 units away from the mean. So the average one is 6.4 away from 0 here. Okay, and this gives you an indication of how close the residuals are. So that's it for today. I think that's actually everything you need for chapter 3. I'll see you again soon.